Matthew Huddleston will be speaking on the societal impact of the rapid commercialization of space.
Thank you. Now, like most of you, I prepared my abstract a year and a half ago, and I was even back then I was thinking about focusing on what can we expect in the near future, and some of that has actually happened in the last year and a half. Things are progressing very quickly, but there's also a lot of in the way things are today, there's a lot of noise out there. It's hard to separate from the voices what really is going on and what is truly possible in terms of space travel. I think particularly for that topic, because we have so many dreams and ideals of what we want to happen. So I'm going to jump in here and present a perspective as a space physicist. I'm not a historian or a sociologist or an economist or someone. So I don't have expertise in those fields, but I can tell you one space physicist perspective on what I see happening now and what I think is possible in the future, and what that might mean and what questions we may need to consider, especially thinking about this ethically. So looking historically, there has always been excitement about space, but it's gone up and down throughout the years, and the predictions about space were actually quite wrong early on. In the 60s, people thought that things would go up and up, like a lot of revolutionary industries, that the number of launches might continue to increase, at least linearly, if not exponentially. And instead, we see a flattening of the curve, and then actually a decline in the space industry. And I remember back in 2005, it being kind of a low point, and being kind of discouraged as someone who was excited about space travel, to just see not much enthusiasm in the public and just a lot of things winding down, the space shuttle program winding down, and not much new on the horizon. But actually things have picked up since then, and we are in what some people call the second space age. And it looks a little bit different. There is more privatization of space, there's more commercial payloads, there's more countries involved. And that may actually bring a difference in the way humans interact with space, space travel. Now, this graph is mainly a graph of the traffic up and down to orbit. You can see, first of all, that there's been very few women involved in space travel as compared to men. That hopefully will change. But also the traffic, number of launches up to orbit and back has gone up and down throughout the years, but the actual total number of people in orbit has stayed pretty stable. There are 10 people in orbit right now, and there's never been more than about 13 people in orbit in the past 35 years, and it's been constant, about a dozen people throughout that time. And in the near future, in the next decade, that may change significantly. Now, the one thing that has increased quite regularly is just the number of objects in orbit, because what goes up does not generally come down. If you put it in orbit, a high enough orbit, it stays up there. And it's only at the lower orbits where there's atmospheric drag, does it eventually degrade and come out of orbit, or if you have propulsion on your spacecraft that can deorbit the craft. And so we see just this general increase in the number of objects in orbit, and there's some dramatic increases on this graph a couple places. This was a missile test that China shot down intentionally as one of its own craft, and produced a lot of debris. And this one in 2009 was actually a collision between a Russian military satellite and an Iridium satellite. And you can see that those were at a fairly low orbit, so there was a deorbiting of some of that debris material. But in general, that's been increasing over time. Now, the one good news is that launch costs have come down, especially in recent history. And there's several reasons for that. Privatization of space, I think, is a big reason. So you have companies actually looking at the costs a little bit more carefully than the government sometimes does, and where cost overruns are just not an option. And SpaceX is the one that's gotten a lot of press, because they have actually done some significant things that people have not done before, including recoverable vehicles in a way that really reduces the cost. The space shuttle program was recoverable, but it was not in a very cost-effective way. And another factor, though, that's really important is the miniaturization of electronics. So that's allowed control systems, guidance systems, all sorts of systems for spacecraft and for rockets that can be lower weight and take up less space and actually outperform anything that was around in decades past. And also there are new materials and fabrication techniques, people 3D printing rocket engines, 3D printing rockets, actually having turbo pumps, the rockets being powered by electric batteries rather than traditional methods. And so these are all things that were not around a decade ago. And so what are people doing with this? There's tourism is something that you might hear a lot about. Suborbital tourism has been in the news in the past month or two with the flights of Virgin Galactic and Blue Origin. And this is the battle of the billionaires. But this is suborbital. Orbital tourism is still about the same place it was in the past, and that may change in the near future, but hasn't yet. But the suborbital tourism is already something that is new, and we're going to see more of. How successful that is commercially, I'm a little bit skeptical, but we'll see. But communication fleets are rising. Starlink satellites, you've probably heard a lot about, but there's more on the horizon. OneWeb, China is planning to launch its own suite of communications satellites, and this is going to have a big impact on the space industry. And then nanosats, picosats, femtosats. This comes from the miniaturization of electronics. Femtosats, these are satellites that are 100 grams or less, and you just couldn't make a satellite that small in the past, but now we can do that. And that opens up the possibility of one launch actually carrying thousands of satellites, just one launch. We already have had launches that have sent out over 100 satellites in just one rocket launch. So challenges, current challenges, already problems that astronomers are dealing with is the interference in their telescope imaging of these satellites suites passing through the field of view. And astronomers are trying to figure out how to develop some guidelines for how some of these satellites are constructed and placed into orbit to minimize these problems. And then there's increased odds of orbital collisions. And as the number of objects in orbit goes up, that just continues to mount. Now, future possibilities. This is what I see as a kind of commercial landscape in the next 50 to 75 years. It doesn't mean it will happen, but it's I think is very definitely possible. What is possible does not always come to pass. There are all sorts of societal factors that play into what actually happens in the development of technology. But it is quite possible that we could have the capacity of sending things to orbit at $100 per kilogram or less, which would lead to a lot more launches of spacecraft. And you could even develop an industry in space debris removal. You could have vacations for the wealthy or the upper middle class, probably not going to be cheap enough for lower income people, but that could become a reality. Very high resolution global monitoring, global usage of satellite internet. Now there's also going to be opportunity for scientific exploration. I'm not going to talk about all of these, but these are things that people have been talking about for a long time that I think could actually happen in the next 50 to 75 years. These are not just things that we dream about. These could be implemented. But there are also some scary possibilities. There are space-based weapons that could be put into place. And as costs come down, that could include non-government entities putting weapons into orbit. And the real-time broad spectrum high resolution global monitoring could be very useful, but also kind of scary every time you walk outdoors if you're being watched. Exponential increase of space debris, and we've talked about that, but also greenhouse emissions from launches could become a problem as the number of launches increases. Right now, it's relatively minor compared to emissions of aircraft, but that could change. And then we could have these big ideas of trying to mitigate climate change by intentionally altering the climate from space. And I could go into that in the question and answer time, but that could be good, but it's still kind of scary to think about those possibilities. Now, I also want to mention things that I believe are not possible in the next 50 to 75 years. And this is just my experience, my perspective as a scientist, is that we are not going to have cities or colonies in orbit on the moon or Mars. As much as people talk about that, I think research stations, very possible, but I really do not see cities or colonies of thousands of people living off the Earth. And I'll come back to that in a second. But a lot of things that are possible are just not going to be cost effective in the near future. And there are certain things like that just you see headlines all the time of these theoretical papers of warp drives or free energy drives or whatever. That's just not going to happen. And Earth-based space elevators, again, I would put into these very kind of dreamlike ideas that if I were to guess what happens 500 years from now, okay, maybe. But in the next 75 years, I just do not see that as a possibility. I won't give all my reasons for that because I don't have time. But it's really important that we think about the ethical considerations given this landscape and the way things are changing. If we really are in a second space age and things are going to be rapidly changing, what should be our motivations and how we engage this? And I think we do have this motivation to explore the world that God has created. And there is ethical value in exploration and discovery. There is also a value in pursuing societal benefits and climate monitoring and improved communication and so on. But we have to use caution. There are, right now, as always, there are these visionaries who tend to drive things, whether we're talking about, Bill Gates or Steve Jobs or Elon Musk. They're going to have blind spots. And we need to make sure that we aren't just following blindly in the direction of wherever these visionaries are taking us without considering the possible consequences. And there is a danger of increased stratification by economic class. And by that, I mean that we could end up with a situation where space and access to space and access to the space-based tools becomes something for the rich only. And I think could be a negative. When we talk about all of this exciting new stuff of the new space age, we want to remain honest. And this is something that I encounter all the time when I hear popularizers of science talk about this, that sometimes we cast the wrong impression. There are these popular myths that somehow we can escape the problems on Earth, get out to orbit, get out to another planet, get out to the moon, and things will be easier. That's just not unscientific, I believe. Living in space is not easier than living on Earth. And I can't imagine a situation it would be until not anywhere in the near future. And science has not discovered life outside of Earth. And we can, talk about how we would love to find it. I hope we do. But we can't try to, motivate people by kind of selling something that isn't there yet, saying, oh, we're going to find bacteria on Mars, we're going to find bacteria on Europa or wherever, to sell our programs. We have to be very careful that we're honest about the fact that we really don't know. Maybe there's nothing out there. And then we also can't guarantee that these breakthrough technologies are going to happen. So here's my closing thoughts. There's certain things that become sort of essential to modern life. And we were just talking about GPS a little bit earlier with Kristine, and that has so pervaded our life now that we think of it as essential. I think there's going to be more space-based technologies that kind of fall into that category. And we want to think about how do we engage this new frontier in ethical and responsible ways. And so we aren't just caught up in the flow and carried along like many technological revolutions in the past. I'll take any questions.
All right, thank you. Jack, I see you have a question.
I do, thanks. From what I know of rocket propulsion, there are many noxious gases and products from launch, but carbon dioxide is not one of them. So where is the greenhouse gas concern?
It depends on the it depends on what is being used for propulsion, and the for the methane, if you're using methane, which is the main, that's the goal for SpaceX, to convert kind of the next generation of rockets is all going to be using methane as a fuel. I I'd have to go back and remind myself of the products of that combustion and whether they can be greenhouse gases. But I remember months ago when I was looking at that, there were some greenhouse gases, it seemed, that resulted from that. So I can't off the top of my head, tell you what those are.
Surely if there's an organic fuel like methane, there would be CO2. I'm just surprised because I thought rocket fuels were mostly solid state except for liquid hydrogen and oxygen.
No, there's quite a variety. A lot are using kerosene, and in fact, that's what SpaceX uses for their Falcon 9 right now. It's for something based on kerosene. So, and then methane is going to be used more, I believe, in the future. There's a variety of fuels out there.
Okay, thank you.
I see a comment that follows up on that from the chat box. From Kurt Wood, can you comment on the environmental impact of space launches? So let's go beyond the fuel. Anything else?
Well, yeah, there are a lot. And it right now, the impact is fairly small just because the number of launches is pretty low compared to, say, the impact of the airline industry. And you think about, there's all sorts of environmental impact of the airline industry. And I think that that is going to be a bigger, I think that's an important point, that there's going to be more than just what's the gases that are put in the air. There's going to be the noise pollution. There's going to be just the safety about sending these rockets up and having them land again. If we're having recoverable vehicles, there's going to be safety issues with all of that. And so there is there are many things to consider as we get to have more and more launches. I think that's going to become a more and more important question. Now, one thing to mention is a lot of these launches might happen, start to happen more offshore, and so have less of an impact than they would otherwise. We're not going to be doing these near big cities likely. And what SpaceX is planning, for example, is having offshore launch and recovery platforms eventually. So that can mitigate some of that.
See a couple questions about debris. Will the number of debris, the amount of debris limit space work? And is there a plan to get rid of debris or address the debris?
Yeah, there are lots of great ideas out there. And there's references you can see. There's one, space debris removal by ground-based lasers. That's for very small sized objects, and you can look at that reference for more information. I think that could be end up being a significant industry, that profitable industry that emerges with a lot of other space-based industries, and that is space debris removal. And people have talked about using nets or other ways to capture debris and deorbit things that are in space. But that's a concern, and it may end up being something that people pay for in the future.
All right, William?
I just want to make an observation. One of the things you mentioned with noise pollution, that also affects rocket testing. I live about 7 miles away from SpaceX's test facility in McGregor, Texas. Not only do we hear every test, we feel every test. Yeah. And their business is going so well, they just announced they're going to double the size of their test site. And that's not really been welcomed very positively by a lot of people, even though it's bringing in jobs. That's going to be a lot more testing.
That's a good point, and I hadn't even thought about that. That's a good, just a lot of the infrastructure that comes up alongside the launch industry is going to be important as well.